Now let's look at compounds of carbon, because carbon has 4 electrons, and we do not expect it making positive C4 plus ions. We should expect 4 covalent bonds for each compound, like in all organic cases. So, first, carbides. Carbon interact with metals, making compounds with C4 minus ions. Example is aluminum carbide that reacts with water to make aluminum hydroxide and CH4 methane. It also reacts with some non-metals like silicon to make silicon carbide and carbon monoxide. Silicon carbide is one of the hardest known compounds, and it's of course much cheaper than diamond. It makes oxide of them carbon monoxide, the simplest, special interest for theory because a loose model fails on it. To draw triple bond as it should be, you need to assume that your oxygen is O plus and your carbon is C minus. It's impossible. Why? Because oxygen is far more electronegative than carbon. The explanation is coming from molecular orbital theory, where you can see that there are 6 electrons at bonding orbitals, which means you have triple bond, but these bonding orbitals are located closer to oxygen than to carbon. As a result, you have oxygen more negative than carbon. Carbon monoxide is received by reaction of carbon with oxygen, but most commonly by reaction of formic acid with sulfuric acid. In this case, formic acid loses water to sulfuric acid, forming sulfuric acid hydrate, and carbon monoxide boils out. Carbon monoxide reacts with oxygen to make CO2, or with chlorine to make phosgene, a very toxic gas that is a good starting material for different synthetic procedures. Carbon monoxide is very helpful for reducing metal oxides. For example, iron trioxide reacts with CO to make iron metal and CO2. It also reacts with hydrogen to make methanol. Other compounds of carbon include disulfide, CS2, which in turn can react with chlorine to make carbon tetrachloride. You also can have reaction of CH4 with ammonia to make cyanide, Cn-, or in form of hydrocyanic acid, HCN. Formally, this is organic compound and Cn- is not.